Let's mute everyone. If you want to ask question, type in the chat. All right. So welcome back, everyone, to our today's session on machine learning from our ArewaDS. So previously we finished the regression from last week, where Dr. Ibrahim took us regression. Today, inshallah, I will take us into classification, which is definitely the next step in this curriculum. Now, just taking us back on what where classification belongs to is, we know we have what we call supervised learning and unsupervised learning, right? So in supervised learning is kind of machine learning where you will be given the input data, you expect what? Input data and output. But unsupervised learning, you just give input data, you don't give any output data, but you do what we call association or clustering. And in supervised learning, we make what we call prediction, but in unsupervised learning, we find what we call patterns, right? Patterns. And in supervised learning, we make prediction, but unsupervised learning, we find patterns in the data. So in supervised learning, we have already classification and regression, which was already discussed. What are they? So today we will move to classification to see how we can use classification. But before we dive in, let me remind us some basic terms, but also let me go to this session, this lesson regression class. Oh, okay, I didn't push it. Okay, I will push it, but I think classification is here. So this is from our repository. This is classification notes. And you can see we have different stuff: introduction to classification, more classify, yet classify, and apply web page. So we'll start with this section defining what is classification. And then, we try to see what this is, like, how you can balance your data, understanding the data, because this is the first stage in machine learning. You need to understand your data before you even start doing modeling. So we'll discuss this more along the way, right? So I think sometimes I explain these ones. These are some of the basic terminologies that we use in machine learning, and it's a good idea to get idea what these stuff are. So here, for example, these are some of the records for, this is a flower. We have what we call sepal length, sepal width, and petal length and petal width. So this is sepal. If you look at this one, this in this flower is called sepal. And this sepal, you can see it has what we call, length and width, right? So for example, this is the, length, this is the width, right? So also here, the sepal, it has length and width. So we have what we call petal, length and width, right? Now, given the length of petal and the, width, and given the length of sepal and width, we can automatically predict a flower is whether it is setosa, you can see class level, whether it is vascular or whether virginica. Now, this is what we said. This information, 1, 2, 3, 4, information about particular object, about particular item, is what we call observations. And what we want to predict here, for example, if the sepal length is 5.1, sepal width is 3.5, petal length and this, then the flower type is setosa. This is some kind of experiment that has been done. They measure the length of each flower, maybe 1,000, 2,000, something like that. So given this is the setosa, and this, so you can train machine learning model. If you have existing data set in this format where you have the information and you have the class you want to predict, then you can use machine learning model to predict given new data. So for example, if you have new flower, now you measure the length and width of the sepal and the petal, And now you use machine learning algorithm to predict which class the flower belongs to, whether it's setosa, vesicular, or virginica. Now, you can see this one is one information about one flower. So one information about flower is what we call instance or observation. So if you have a data set in maybe Excel, each row is what we call instance or observation. So in machine learning lingo, you will be hearing these words, instance or observation. So whenever you hear instance, they are talking about the rows value. So this is an instance. Now, okay, we said this is row or instance or observation. But what about a particular value for that flower? It's what we call future. Or all these ones from here to here, these are all futures of this flower. These are all futures. You can see it contains S, right? Because there are many variables that define this one. We have the sepal length, sepal width, petal length, petal width. That is why it's called futures. So you can see it is now called inputs sometimes. It calls attributes, it called measurement, it's called dimensions. So all these features, they are called with different names. So in machine learning lingo, if you hear something like this, what are the features? So the features are the observation of your data. Now we have the final one, class level. So class level is what we want to predict. We call class levels target or outcomes. So here you can see setosa, vesicular. We have 3 class levels. They are called targets or outcomes. These are some very basics, terminologies you need to understand so that when we move on, when you hear me talking, what is a target? So you said, that is what I want to predict. Or when I say, what will be the outcomes? You say, okay, that's what I want to predict, right? So these are some of the basic, features that we should know about data when we are given in machine learning. Any question? All right. So when we come to the machine learning, you see that this you will be given, for example, look at this one from 1 to 50. And then here, dash, 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 we have up to 150. We have what we call training example. So you may be given some data here as training example, for example, 1 to 50. And you may be given another data as, testing example. So you can see here, training example, a row in a table representing data set. A row in a table representing data set. That are what we call training examples. So you may be given like, what are the example, training examples? So all this one are training example. And we call them with different names, as you can see, observations, instance observation. We even call them record, or sample. We even call them sample. And all these, futures. So this and this and this and these are called futures. So when we come to doing machine learning, futures are, indicated as X. You can see future, a column in a data table. You can see a column, in a data table is called future. And we have target, abbreviated as small y. Synonyms with outcome, you can see is called outcome, or, response variable as well, dependent variable. You can see different names. This is called outcomes, dependent variable, or class level, or ground truth. All these names, we use them in machine learning. So when I talk to you in this data, what is the ground truth of this data set? We can say the ground truth is setosa, vesicular, virginica, because these are the ground truth, the values that we want to predict. So these are some of the, basic terminology you may want to learn, because when we move into the detail, yeah. Now, again, let me reiterate some of the, pipeline for doing machine learning. So for us to do machine learning, there are several steps, and some of the steps take much time than other steps. We have, you can see the first step here, we have what we call raw data collection. So when you want to do machine learning, here you can see that we are doing example, you see off the shelf data set, you would say, okay, this is example data, do machine learning. But for example, you want to do project in machine learning as your master's degree project or undergraduate degree project, maybe you need to look some problem. Okay, you want to predict, the crime rate or banditry in Nigeria. You want to predict where it's going to happen. So you see, you need to get data. Maybe you need to get data in Kaduna, the crime happens, banditry in this location, in area, in this, you need to collect data. That is the first thing you need to do if you want to do machine learning, collect data. So you can see raw data collection, which from your data set. But when you collect the data, you must do some kind of what we call processing. You need to remove, process the data, remove some other stuff such as redundancy and, a lot of other things. This is what we call processing. And then when you have your data, you process the data, then you now take your machine learning algorithm. You take your machine learning algorithm and now apply the machine learning algorithm on your data. But before you apply your machine learning algorithm on your data, you need to divide your data set into two classes. We have what we call training data and we have what we call test data. And then, you train your machine learning model on training data and you evaluate it finally on test data. And now you have this. So this is the complete pipeline for when you want to train machine learning model. We'll come back to it when we want to do. But data collection and data processing take much of people that are using machine learning much time than even training machine learning model. So for example, you can see here, 70%, 76% of data scientists spend their time preparing data. 76% of their time is spent preparing data. Training machine learning is just the last part, like just 5% of your time. So when you are doing machine learning, what you need to do is make sure you create a very good data set. A very good data, because when you don't have a very good data set, your machine learning model will be useless. So that's why data scientists and machine learning spend, as you can see, 70% of their time cleaning data, preparing the data. So you can see here, they live in the data scientists or machine learning, 90% of their time collecting data. So you want to create the data set, predict crime in Nigeria. You need to go to Kaduna. You need to go, your time you need to get, cleaning. Now, when you collect the data, you need to clean the data. Okay, you put them, this is the data set from Kaduna, this is from Abuja, this, clean and put the data. It takes 60% of the time, building machine learning model, you can see what? Building machine learning model, only 7%. That means in machine learning, if you are a machine learning engineer or you are a machine learning scientist or you're a student, training machine learning model is not the most difficult part. The most difficult part is getting your data, putting the data in the good shape that is ready to be given to machine learning model. So this part, data collection, processing the data, you can see that processing the data, all these ones take the most amount of your time. When you have your data, process training data, you can see that processed, that is you finish processing, then you can just fit it into machine learning algorithm. Just fit it. So fitting it into machine learning algorithm can take like, few minutes to train the machine learning algorithm. So just to reiterate, in machine learning and data science, modeling is not the most consuming and most difficult part. The most difficult and time-consuming part is cleaning, getting your data. So for example, you want to predict election in Nigeria, who is going to win between Buhari and Tinubu. So if you want to predict who is going to win between Buhari and Tinubu, you need to go to, for example, social media, Twitter, Facebook to collect your data, right? To collect this data. Now you need to go to Twitter, collect data. You need to go to Facebook to collect data and put all this data together, process them, clean them, put them in a shape. Putting them in a shape is to put them like in this form of order that can be ready to machine learning model. This is the lion's share of training, on this one. So some of the common process, because we said 90%, 70, we say 70% take time to process the data. So what are these common processing steps? So the first one, we have data cleaning. Data cleaning. So for example, duplicates. Example, you collect data and you find that you want to predict, some kind of, who is going to win election, and you have a lot of duplicate. You collect you collect data set from Twitter, and in an effort to collect the data, you have a lot of duplicate data. So when you train a machine learning model with duplicate data, it doesn't
improve performance. It doesn't do anything. What you need to do, you first need to remove, redundant data duplicates. So that's why you see here we say remove duplicate. Ensure your data does not have repeated entries. Handling missing values. Now, if for example here I have a data set, I have missing value. There is no value here. There is no value here. There is missing value in your data set. When you train your machine learning model with missing values, it will not perform well. Now, when you have your data and you have missing values, you make sure you clean the data. You make sure that the data there is no missing value, you fill in. There are many ways to fill in missing values. So, for example, for data set of house prices, if some entries are missing in the number of bedroom, you need to fill those entries. Now, there are many techniques for filling missing values. So, for example, here you see there is no value here, but here there is value, here there is value. One way to fill in missing value is just to take average of the adjacent. This plus this divided by 2. You just fill in here. You say that is, you fill in the missing values. I mean, there are many techniques that you can use for missing values, in that. So let me show. So for example, what we can say, what are techniques for missing values. So you can see here, handle missing values, drop missing values. So in fact, if you find, your one of this row, this value is missing, you don't need to proceed and train your machine learning model. You can just drop this row, just drop it. If you have large amount of data, for example, 30,000, and, if you have 30,000 and 2,000, they have missing value in them, you can just drop them. But if you have, for example, 500 and 100, they have missing value, don't drop them. Do what we call interpolation, or fill in missing value. So for example, you can see here I just find a lot of strategies to fill in missing values that we are not here to discuss all of them. So one of them is to drop missing value. Number 2 is fill in imputation with the mean or median or mode. What I mean by imputation is that if we have here, and here is missing, you can mean this plus this and calculate this and take the median. Can you see that? Or mean. So for example, if here is missing and I have here, I have here, I can sum all of this one here and take the mean and do. So there are a lot of you can find out more about this filling missing value. We have what we call forward fill and backward fill. So forward fill is something like this. If, for example, I have this, is not missing value, I have this data, but this one is missing, but this is not missing, this is not missing. Only this one is missing. Now, in forward fill, you said, because here is missing and here it's not missing, maybe likely I can use this value 6.4 and just put it here. That's what we call forward fill. Backward fill is, maybe I just take this value and put it here. That is what we call backward fill. So you can see this is Handels method fill any that do backward fill and forward. Predictive imputation, you can even use machine learning model to predict the missing value. So you see there are a lot of methods that you can dive into. This is something that something that you can explore. There are a lot of methods. So that's what we call filling missing value. So you see when you have data, the missing value you can do data transformation. So for example, we have what we call data transformation as well. It's one of the pre-processing techniques. So what does that mean, data processing? So for example, now data normalization. For example, now you have data set where you have some futures and there we have salary and age. So for example, here you can see these are our future, sepal length and sepal width, right? We can see the values are close, like 5.1, 3.5. They are within, the same, But for example, we have a feature called age. We have feature called salary. You can see the age of a person range from, maybe 3, 4, 5, 6, 7, up to 20, 60, right? But salary can be 1 million. So if here the age is 20, here the age of another person is 30, here is 40, but their salary is 35,000, 60,000, 300,000. You can see there is a difference between the age and salary. The values are very diverse. So we do what we call normalization. That is scale the numeric, all the value into 0 to 1. So what we can do, because if you train a machine learning model and these values, they are within like, 1 to 60 the years, and these values, they are, the salary is like 300, you can see they are different. So when you train machine learning model with futures that have different kind of scale, it may not perform well. So one good thing to do train machine learning model, if your data is such kind, you scale it into 0. That is what we call normalization. So you can see this is what I mean by normalization. Scale numeric data to standard range without distorting difference in the range values. Example, in a data set feature like age and salary, normalization ensures this feature contribute equally to the model. Because if you train the machine learning model, this is age, and this is year salary with large amount, this one salary with large amount of values contribute more to the model. So we need to scale it. So you can see there are a lot of, data pre-processing techniques that we may not actually, go through. For example, feature encoding. So for example, here, feature encoding. When you have, for example, some of the features in your machine learning model, here, for example, I have a feature called color, and the color here, I have blue, red, green. So in that case, you don't need to use red, green, and whatsoever. You can do what we call map them. Red may be 0, red may be 1, and whatsoever. This is what we call, future encoding. You can map the color into this. Future selection. So sometimes when you are given data, for example, house data that we have seen before, you don't need necessarily to go and just train your machine learning model with all the features. For example, I have a data set here, and these are the features. I have many features. Maybe I have 50 features. Does that mean if you have a data set with 50 features, you just move on and train your machine learning model with 50 features? No. Because some features are not actually, good. You can drop them. They don't make any they don't necessarily give a lot of information, right? So we will have what we call feature selection. For example, you can drop all related, data that in your house. For example, for predicting house price, in a data set of predicting house price, the color of the house might be irrelevant. So when you have given, data for houses, maybe the location of the house, the price of the house, number of rooms, number of toilet, these features can determine the location, where it's in Abuja, number of rooms, 3 or 5. Another feature, for example, whether the year of the house, right? All these can help to, when predicting the new price of the house, but the color of the house may not help. So if you have a feature called color for the house, you can drop that feature. This is what we call feature selection. Data splitting. So when we come to machine learning, we split data into trained and tested. We have also data balancing. So for example, let me give you an example. When you are given data, for example, to train, we have this, our data, and it turns out that we have setosa, we have vascular, we have vaginica. When we have, for example, setosa, it is, we can see we have from 1 to 150. Now, when we have setosa, maybe in the data set from 1 to 50 is 100. And we have vascular is 40. And while we have vaginica is only 10. So you can see we have 100, 40, 10. You can see the data is not balanced. A machine learning model trained on unbalanced data will not perform well. You need to do some data processing to make your data set balanced. That's what we mean by data balancing. You can see in a data set with 90% positive and 10% negative, oversampling can. So these are some of a lot of steps. So you can see we have a lot of steps to do data processing that you can. In fact, there is a book separate dedicated for data processing for machine learning that we can see. Let me or we call them maybe feature engineering. Feature engineering. All these ones, for example, we call them feature engineering as well. Book. Let me. So, for example, let me show us here. When we say this, you can see we have, for example, feature engineering. You can see this is feature engineering. So what I showed, for example, is what we call feature engineering. For example, data normalization, feature selection, all this one as some way. So you can see there is books dedicated only for feature engineering. So this is not something that we can discuss all in this session. So you can see this one, feature engineering, by Max Kuhn. When we, click this one. That is a free version of this book. We can see this is a free version of this book, Future Engineering. But the book was written from using R programming. So you can see here, Future Engineering and Selection, a practical approach. So you can see, you can see splitting, pre-processing, data splitting, tuning, sampling, visualizing, so you can see future encoding. So you can see these are a lot of stuff for future, for machine learning to do. So all those steps are meant to prepare your data, before, before you move on. Right. Any question? Any question? Okay. So now we have seen this. All these steps are not linear. What we mean by not linear is that it's not like from this step to move this step. It's just like you can do this and iterate and and move on. Okay. So now when you prepare your data, we have your raw data, you do all these feature, dimensionality reduction, all of this. When you have your data ready, training data set, process training data set, you have your data set ready for modeling, then you feed it into machine learning model. That is it. So all these ones, they are the one that takes a lot of time, but this one is this. So training machine learning, then the next step is just training your machine learning model, right? But how can you select machine learning model to make prediction? There are many machine learning algorithms that can use. We have, for example, some of the machine learning algorithm. Let me show us. Okay, list of machine learning algorithm. Okay, but let me see. Okay, so let me show us this. So for example here, if you want to do classification, we have a lot of algorithms that can be used for classification algorithms. You can see we have artificial learning, we have decision trees, we have ensemble learning. So for example, here you can see we have ArewaDS. All these one are different machine learning algorithms that you can use to train machine learning model. You can see them boosting, code training, decision tree, deductive, k-nearest neighbor, kernel, linear discriminant and linear classifier, logic, all these ones, all these one perceptron. These we have many machine learning algorithms to choose from. For example, now let me say I can choose here decision tree algorithm. So decision tree. So you can see this is an algorithm, with a lot of mathematics, mathematical, how the decision tree, with a lot of explanation, how it works and whatsoever. You can see explanation, decision tree. You can see how all this stuff. So we have a lot of algorithm to do classification. We have a lot of algorithm as well to do regression. But in this, our session, we don't need to bother about the details, like, the mathematical concept behind all these machine learning algorithm. We have off-the-shelf tool to provide us with this implementation of this machine learning algorithm. This is what we call scikit-learn. So scikit-learn, you see, this is it, scikit-learn. Scikit-learn is a Python machine learning Python library that implement machine learning algorithm, whether it is classification, regression, clustering. You don't need to know the detail, because when I told you, like, how to random forest works, when we talk how to random forest work, it's a lot of mathematics and whatsoever. But we are doing applied machine learning. You don't need to know the details, but if you go further, maybe in the next step, you can learn the details behind the machine learning algorithm. So for example, as I said, we have classification, regression. So when we go to, for example, classification, look at different kind of machine learning algorithm. We have what we call linear models. You can see, mathematical concept to explain what happens. So we have what we call linear models. You can see them. We have linear and quadratic. We have kernel. We have support vector machine. We have stochastic degradient method. We have nearest neighbor. We have Gaussian naive bias, decision trees, ensemble. You can see all these ones. They are, you can use, neural network. You can use to train machine learning classification. But then, we have regression as well. We have, different kind of algorithms to use for regression. In fact, algorithm that can be used for regression, some of the algorithms can be used for both regression and classification. Now, so thank God, classifications, scikit-learn implement all these algorithms. We don't need to care about them. So for example, let me go to nearest neighbors, and you can see nearest neighbor. When we go to this algorithm, k nearest neighbor, if you want to see the implementation, you can go to, I think, anyway, they don't have the implementation here, by the way. So let's move on. But what the point I want to say is that all models are wrong, but few are useful. What this means is that not all the algorithms can work. You need to select these and try it. Does this work? If it doesn't work, you train this. So you may end up trying maybe 10 different algorithms for classification. And after all, you can select, the one that works best. So this is it. So we have many machine learning algorithms. How can you select one for your data? So you can try 10, something like that, and select the best one. And then finally, evaluate models. So finally, when you train your machine learning model, you now evaluate on the test data, and then, final evaluation. So that's the process for machine learning. I just took us back to reflect on what you have done so that we are refreshed. So Dr. Ibrahim, discuss about regression. So we'll discuss about classification. As I said previously, classifications allow us to classify things into this and that, right? Different classes. Unlike regression, where it predicts continuous values, right? So we will use scikit-learn at it, allow us to do a lot of stuff. So in fact, scikit-learn can allow you to do classification, regression, clustering, dimensionality regression, and even model selection. So even pre-processing. So you see, we said that you can do pre-processing before your machine learn. So scikit-learn not only it provide algorithms, but you can also do some pre-processing and feature selection with scikit-learn. So scikit-learn is the first place to go when you want to do machine learning in Python. All right. So having said that, let's move on to this is our introduction to classification. So we introduce what classification is. So you can see this is spam or no spam, latest or class, and then what we can do now is we want us to do to work on a data set that you already work on, which is what is it called? What is the name of the data? Cousin, right? You already discussed this data with Dr. Ibrahim, right? That's that correct? In your previous session regression, you discussed cousin, right? So let's what this session in this notebook is talking about is that, as I told you, they want to use cousin data set to train machine learning classifier. But as I said, before you train machine learning classifier, what do you need to do? You first need to spend time, right? As I said, 70%, observing your data, understanding the data, cleaning the data, right? The training machine learning is the last part, and it takes few seconds, few minutes. 2 to 3, 5 minutes, 6, 7 minutes to train machine learning model. But understanding your data, clean the data, put it in a shop for prediction, that what takes much time. So here they took us cleaning and balancing the data, because the data is not balanced, which is cousin data is not balanced and it's not clean. So they took time here to show us the first step, which is cleaning and balancing your data before you train your machine learning. So they take out this first step to clean the data, and now after cleaning the data, the next session discuss about training the machine learning model. So now let us dive into clean the data, because it's very important, right? Cleaning your machine learning model is very important, right? So let's import our data set. We already know this. And now I load my data set, which is cuisine data set. We already know this data, right? And now, PD, the read CSV, we already know that this is how you read CSV, how you read your file. I have the file here, CSV. You can see it, cuisine CSV. Can you see that, right? This is my file, cuisine CSV. And okay, so this is my file, cuisine CSV. And you can see, okay, I have this cuisine CSV. And yeah, so for example, here you can see I DF head to see the data set. So this is a data set, but here you can see I have some extension here when I can open this data to just view it here as well. So you can see here, this will allow me to view my data set. This is kind of graphical representation, data munging stuff in VS Code. So you can see here, this is cuisine data. You can see, we have Indian with Thai food, and this is, the ingredient of the food. We have almond, the ingredient Angelica, whatsoever, apple brandy, all this stuff. Yeah. So what this means is that we have almond, Indian food, and does this cuisine contain almond? They say no. If you see one, it means it contains this category. So this is just about the data set. If you are using Jupyter Notebook, I think this package is called Data Wrangler. If you want to see it here, you can come Data Wrangler, I think. Data. You can install its extension in VS Code, Data Wrangler. Is it Wrangler? Yeah, Data Wrangler. This is it. So if you install this extension, it allows you to view your data in a different way. So for example, you can even do this and preview here, open in Data Wrangler. You can open it. Can you see that? I open the VS, my service in Data Wrangler. So you can see it will open here, something like that. So this is a cool extension in your Jupyter Notebook in VS Code, right? So yeah, so now here we see this. Now, as I explained, the row in each represent unique recipe. So here you can see the row here represent unique recipe. So in an Indian recipe, you can see we have a different recipe. It's Indian and it contains almond. There are a lot of stuff. So each row, as we already said, is an instance, right, or observation. And the column here, this is the kind of cuisine, and here these are the features of that. So I want to get the information about data. So you can see I have how many columns do I have? 385 entries, right? Because I may not know, like, I cannot keep moving like this to see how many, entries do I have, so you have, these entries, and, you have this. And how many cuisine we have. So here you can see, I want to find out how many cuisine do we have, this stuff. So here we can see we say dear unique. So here it's showing me we have Indian, Thai food, Chinese food, Japanese, Korean, right? So this is, we are all familiar with Python, right? So this allow you to get the unique of this stuff, right? If you don't understand this, I can, for example, put this one here in my chat and say, okay, explain what this does. Explain what this does. Explain what this does. Oh, in fact, we have explain. Okay, yeah, explain. You can see I have explain. Can you see? I have explain here. I can now put my code, so it will automatically explain what this means. So this is something that one can, actually, while you are doing programming, you can try. So you can see this line of code return an array of all unique value in the cuisines. You can see that. For example, something like that, it return this. So this is something that when you are doing, you don't need to go anywhere from your VS Code. So you can see we have this, right? So, but we have food for Indian, Thai, Chinese, Japan. So, but how many data do we have for each Indian and whatsoever? How many instances do we have? So here you can see I set the data for Thai, because this is a DF data frame. Remember this data frame DF. So I want to remove all the rows where it is Indian, right? I want to remove all the row where it is Indian. That is so you can see dear cuisine, where it's equal to Thai, where it's equal to this, where it's equal to Japan, where it's equal to Korean. So I name them Thai data frame, I name them Japanese data frame, Chinese data frame, Indian data frame, Korean data frame. So this is how you subset data. So you can see here. Now, when we subset them, now we want to see how many do they have? How many instances do they have for each one? So you can see here, I print Thai data frame, Thai df.shape. So here shape, remember what it is. So you can see, because here it's in string, it's a .df shape. This return the rows, this number of columns, because we have the same number of columns, right? So you can see that. So here we have 28 for Thai food, 320 for Japanese, Chinese food is 442, Indian is 598, Korean is 700. So from here, we can even observe that there is kind of imbalance in data set. So if you want to go to train a machine learning model to predict which cuisine, which kind of cuisine is that, from here, you can even understand, oh, right, I have different instances for each class. I have Thai is 289, I have Korean 799. When you train your machine learning model with this kind of imbalanced data set, your machine learning model will not be good. So now you need to explore ways. Maybe you need to collect more instances for Thai, collect more so that the maybe something like this close to this. So you need to balance the data. This is what we call, you can see, data imbalance. So you know, I can use this as well, value counts to see how many unique do I have. You can see Korean, and you know, this is the instant, how many instance values do we have in each data set. So you can see from here, I didn't just go to train my machine learning model. I just come down and say, okay, let me observe my data and try to figure out if there are any issue that needs to be, you know, dealt with before I train machine learning model. Yes, now we identify one, which is the data is not balanced. So before you train your machine learning model, you need to go and balance your data set. There are many ways to balance the data set. Number one, we have what we call upsampling. Upsampling. So for example, here, you have Korean is 799, right? And Thai is 289, right? Now, upsampling is a way to upsample from 2899 to be like close to this one. We have what we call downsampling. Maybe we don't have, maybe all this data set, they are within the range of 200, 250, 289, 260. They are within the range of this, but only Korean, that is 799. So instead to upsample this one to this ones to this, you can what we call downsampling. So you need to downsample this 799 to range of 289, you know, 250 within this range. That's what we call downsampling and what? Upsampling. In fact, we have a machine learning library or Python library that do this kind of imbalance classification. So when you have a data which is imbalanced, you can use this library to balance it. But if you have much time, you can collect more data. But this library, what it's doing, for example, if you want to do upsampling, for example, from 289 to 799, it will replicate some instances here and change some value. There are some detail about this. There are algorithms that do upsampling and so, but we don't care about the detailed nitty-gritty. What we care is just, if you want to do upsampling, you can call your machine learning algorithm. So here, in fact, we have what we call imbalanced learn. What this does is basically a Python library that helps you to, you know, make sure your data, you know, balance. So what this shows. So you can see this is imbalanced LAN. So when you have data set that's imbalanced, you can use this, you know, to balance your data set. So for example, we will see that when we come. We will go through that. Okay. So any question before we move on? Any question? Okay. Now we have seen one problem with our data set, which is it has, you know, there is no balance. So we need to balance it. We need to take care. But let's also discover the ingredient. Let's look at the ingredient in the data set. So here we can see this is the cuisine. These are the ingredient, right? And these are the, this. So let's all do some observation, right? Now, what we want to do is, because we have many ingredients, what about the most common ones or top 10? Top 10 ingredient, that appears within each one. So we want to answer this question. So you can see this data set, and then we can see sometimes, we can sometimes in data, you need to transform your data to make it in a way that you can be able to see. So what I want to do now is I want to see how many elements do I have. So for example, you see I have element here 1, all this. So I want to sum all the values that I have. Element is 1, Angelica 0, 0, 0. I want to sum everything. Now, what can I do? So let me show us what we can do. So here we have what we call T transpose, which is a function that transfers your data. So here you can see now I transfer the data, that is the rows. You can see here turn into here. You can see them. And this row column, this one here, they are now here. Can you see them here? So this is what we call transposing your data set. So if now I transpose my data set, it means that I now have, Angelica here, right? And Angelica, I can sum all the values here. If I sum all the values here, then that means this is the total of Angelica. Almond, if I sum all the values here, 1, 2, whatsoever, if at the end, if I sum them, then it will be the total almond. So here we can find out what are the top ingredient, right? But what about this one? This is not ingredient, and this row we can remove them. So we can remove this ingredient, right? So you can see here I can drop. So we have a function called drop. You can see I on top of transpose, I now call another function called drop to drop what? Cousin and unnamed, right? So this function drop, what it does is that it drops rows based on row value. So here you can see it will drop cousin and unnamed. So here you can see it drop this one and drop this one. So when I run this one here, you can see it drop them. You can see I have only the ingredient, and this is the instances, right? Now I want to sum along this axis, sum them along this axis, right? I want to sum along the axis. So here you can see I say along the axis 1, which will sum along this axis. And now when I run this one, you can see I have almond is 45, Angelica is this, this is yogurt 125, 145, right? But it gives me how many ingredients do I have and how much each one. But because this is not, arranged in a way like ascending or descending, I can also again call another function to do arrange in ascending or descending order, right? So you can see here, okay. So you can see here, this is float, right? And this is what we call from data frame. You can see here, this gives us what do you call this? It's not a data frame, but rather it is
Pandas series.
Yeah, series. It's series. Yeah, it's Pandas series. So we want to change it to data frame so that we'll be able to see it and call and even give this one columns name. So here we can see we now push it to frame. So this function to frame is something that can, this one will result a series, right? It will give out this series. So now you can call the function to frame and put something, it will now change this one to data frame. So you can see here we have value, we have all this. So if you don't know what this does, the frame, we can check it here. What is this? Explain, this frame. So you can see it can explain what this is. So the frame method is used to convert Pandas series into data frame. Can you see that? So here we convert Pandas series into data frame. Yeah, of course. So you can see we have the values here, but they are not, arranged in ascending or descending order. We can do that as well. So here we, but again, you can see some are 0. So some ingredients are 0. They are not in any of these. So we want to remove them. So for us to remove them here, we do some kind of transport again to change the data into here. And now when we do transport, then we say ingredient, the TF, that the transport, where it's not 0, it's not equal to 0. It returns true, false, and whatsoever. This return, we want to do what we call selection based on logic selection. Yeah. So here you can see we do ingredient here. Ingredient is not 0. Any that is return where ingredient is not 0.
that is what this means. We have already learned Python how to do all this one. So here would give us ingredient. And then finally we run this guy. You can see we remove the where is 0. And again, finally, we can sort ingredient. We have the sort values where you can sort the values based on, values. You can see garlic. You can see we sort the values here. So this is something that you can see here from this GitHub repository in our ArewaDS. You can see, you can see them here. Yeah, right. So you can see them here. So, but here they didn't they create a function, only one function that do everything here. You can see this is a single function. So I took it like just to divide it, to dissect it, to show you what this means. So they want to create a function to apply on the data set. So what this means is that you can see them putting it all together. We put all, what we have to create a function in Python, is to, do this and put all your steps here to create a function. So here we create a function called create ingredient, right? So here you can see it create ingredient, putting them all together for a particular data. Given a data, it will create ingredient, because here you can see all the steps I showed you, we were able to create ingredient, right? For particular stuff. So here we create a function, putting them all together. But what we want to do now is we want to take each of these cuisine and find what are the ingredient. This ingredient is for the whole that I show you, is for the whole cuisine. So, but we want to take, each cuisine to find what it is ingredient. So here, let's go back. This is our original data set. Let me pause to ask question if there is any, because I know I'll go fast because I was looking at the time. Any question? Yeah, if you have question, you can ask before we move. Okay, there's no question. Okay, you can type in the channel chat if you have questions so that I can get back to you. Right. So yeah, so let me go back to the data set originally. So this is our data set. We can see that cuisine and all this stuff, right? Now I want to filter the cuisine data set, Thai data set. This is how we can filter only the Thai cuisine, because I want to find the ingredient of Thai cuisine. So I want to remove only Thai. So here you can see I remove where it is Thai, and now you can see this is only the Thai data set, right? This is the Thai data set. Yeah, cuisine. And so these are the ingredient, all the ingredients. Some are not even a Thai. So what we can do is we can call this function create ingredient. You can see this function that process all the data and just give us this ingredient. So now, given any data frame and call this function, it will just return, that stuff. So here you can see I call this function on the Thai data frame. You can see here, because I saved the data frame in Thai. Now I call the data, so you can see it gives me the ingredient for the Thai data frame. You can see we have garlic, we have fish, we have this, and yeah, we can plot the Thai data frame with the top 10 ingredient, because we have many ingredient, right? Some are top 10. You can see these are the top 10 ingredient: garlic, fish, all this stuff, right? We can also do the same with Japanese, data set. You can see here, I can create for Japanese because I already filter for Japanese for all this data set. You can see here, I create Japanese DF, Chinese DF, Indian DF, Korean DF. I already create the data set for each cuisine. So here as well, we can create, I don't need to, show it here, but here I just show us here how we filter that, but we already did that in this, but we can do it if you like. So you can see here, you can see Japanese data set, the same thing, plot the top 10, soups, rice, ginger, garlic. I can see garlic and ginger in anyone. Chinese data set, you can see the same thing. Chinese data set, we have this at the top 10. We have garlic as well. Indian, we have ginger, Korea, we have this, we have rice as well. So what is common among these data frames, all these data? So who can tell us what is common? So if you go here, here you cannot see, here you cannot see this stuff. Okay. Who can tell us what is common among all these stuff? So let me show us what is common. Who can guess? Who can guess common?
From the graphs, they tend to be a decrease from garlic to chicken. There's a decrease in this thing in size, or in, let me say something like that.
Yeah, but yeah, common in all this one you can see. Yeah, so somebody here, Rahma, is telling us rice, garlic,
Ginger and garlic.
Yeah, so you can see here, we can see we have rice, we have ginger, garlic. Here we have this. What about this one? Rice, garlic, ginger. We have this one here. What about this one? Rice, garlic, ginger, right? What about this one? Rice, garlic, ginger. What about this one? Rice, garlic, ginger. So this means that we have what is called some feature that is common in all this data set, right? In all these, in all this cuisine. Now, because we want to, train machine learning model, if we have these common features, something in everyone, we can drop them. They cannot help in trying the model. What we want is to have something that varies, that is not in every, in every data set. If you go back to our data processing step, we made mention of something here. What is it called? Future selection, irrelevant futures, but not this one as well. That is what is called collinearity. Maybe we may not, we don't need to discuss that. If you have this, okay, here I didn't mention it. Anyway, let's move on. So what I'm trying to say is that because we want to predict, given some ingredient, we want to predict which cuisine is. So if we have some ingredient that are common in this data, in these cuisines, we can drop them. So this is something, one observation we can find now in our data set, because we want to use this data set to predict. So you can see here, we need distinct ingredient. This is distinct. I want to say distinct. So we can drop the most common ingredient that create confusion between distinct, because in common are rice, garlic, and ginger. So here you can see we can use drop. Remember, drop is used to drop rows. We can drop raw cuisine or name rice, garlic, and ginger. That is, our rows. Let's go back. Write the data. Yeah, we want to drop this on name, cuisine, rice and ginger, something like that. In this future, we want to drop it. So this is how we drop these rows. Yeah, and now we can see here, we have future data frame, we have levels. So yeah, so we can see here we have our our data. Let me show something. DF. Remember, this is our data set. We have cuisine here. This is cuisine, right? And these are the futures. These are the futures. These are the futures. Because cuisine is what we want to predict, right? We want to predict cuisine, but all these one are futures. So this means that we can have something like drop cuisine here, drop cuisine on name, rice, garlic, and ginger, and then everything are now assigned to futures. And the levels is just to take cuisine, df.cuisine. Only this one, df cuisine, is our level. So you can see this is our future and this is our level. So this you can see this is a lot of steps in understanding your data. So you use also visualization to understand your data. What happens to your data set is your data set, have some common stuff, has some missing value and whatsoever and stuff. So this is what has been discussed here from this repository. Now the next thing is we can, balance our data set. As I said, our data set is not balanced. We have seen some stuff. We need to balance it. I think we are already on top of our added 7 minutes. So what we can do is tomorrow we can continue balancing the data set. Then we can train machine learning model with the data. Yeah, this sounds good, everyone. Any question? So here we can stop here. We have now, you can see now, we open up the data set. It takes us a lot of time, right? It takes us a lot of time trying to understand the data, explore the data, and other stuff. And you can see when we come to doing learning model, it will not take us any long time to do that. It will just take a few minutes to train machine learning model. All right, any question? You can please as well look at the GitHub repository to see the example they did before we come tomorrow to do the classification. So today we, at the end of this today, what we learned that there are various steps to do machine learning, to train machine learning model, which involve getting the data, processing the data, cleaning the data, which we already made mention that cleaning the data and getting the data is one of the top, pipeline in the pipeline that take a lot of time. It takes your time to prepare the data. Modeling is taking a very few amount of your time to do the modeling. We understand that, and we also look at some of the common pre-processing that you use, for example, removing duplicate data, cleaning, data transformation, encoding, feature selection, data splitting. All these one are some of the features that you can use, processing that are used for training machine learning model. Then we also said that, okay, now after you clean your data, we want to go for training. There are many models to choose from, so you can select best model. But there are some models that are far better than any one, some of them, but we can discuss this when we come. And now we look at looking at the data, how you can clean data, how you can look at some of the observation, and then inshallah tomorrow we will continue from these where we will be able to see how we can balance the data set. After balancing, then we can train machine learning model with the data. All right, so here we stop. If there's any question, feel free to ask, please. Any question? Yau ba a tambaya, ana kwa ganewa? Ana ganewa ko ba tambaya?
Kasar rana ta yi gashi kana gudu. Rana ta yi gashi ka dan yi gudu. Amma dai an gane sosai.
Yani na yi gudu, ina sauri ko?
Yau ba laifi.
Na ce muku ina sauri ku ce min na tsaya. Yeah. All right. Okay.
Zamu na cewa ka tsaya.
Zamu
na cewa ka tsaya.
Doctor kai ne? Right. So yeah, idan ina sauri, just stop me, and if you have question as well. So, okay, the explanation is okay, well understand. Okay. All right. So thank you very much. Tomorrow we'll just see how we can train our machine learning model. Classify. We can train many machine learning model tomorrow and see which one is will work well. But before then, you can also look at them and come with your question tomorrow. All right. Okay. So without any question, we see tomorrow, inshallah. Bye-bye.
Thank you. Thank you, sir. Thank you. Bye.